We can start this lecture with a thought process: power does not corrupt a person, it reveals the corrupted mind of a person. In the last lecture, we discussed about how the iron was being used in ancient India, and we had taken several examples and also evidences for that. And today we will be discussing about the iron smelting process that was used in ancient India. The traditional iron smelting practice consists 6 steps. First is, of course, one has to collect the raw materials and one has to prepare it properly. Construction of furnace and tire pipe is also very important, and one has to make and fix air bellows properly, and ignition and furnace operation, removal of slag and handling of earth sponge iron. Secondary refining of iron bloom is also another way, process one has to use it. And collection and preparation of raw materials is very important, and let us see how ancient people were doing it. And we know that there is several ores like hematites, limonites ores were being used, and also some of the magnetites sand were used for the production of the iron. And evidence is there that mining in ancient India was carried out even at the depth of 20 meters from the ground level. And generally the people, wherever they will get iron ore, they will try to smelt it there itself, and or they can choose another place, particularly the forest area, where the wood charcoal will be available, or they can make the charcoal from the dry wood in the forest. And it is not only the man who will be involved in the smelting process. Women also were involved earlier time during the smelting process, and particularly for transporting the ore and dig it out after performing puja. Puja or the worship was very important, and generally it is being carried out by women for the successful smelting of iron. So, if you look at the iron ore and has to be collected, and one has to identify that, and most of the furnaces use hematites and limonite containing around 30 to 40% ore, iron ore, which are mined around from 2 to 50 meter from the ground level. And once they get these iron ores from the mines, they will be trying to dry it using the sun rays, and also they were breaking into the pieces of size something 5 to 6 mm. Sometimes if moisture is more in the iron ores, what they will be did, they will be heating it at a low temperature, so that excess moisture will be removed. And in some regions like Assam or South India, magnetite is being handled differently, because magnetite is a different kind of ore, iron ore has to be handled. Beside this, they were also producing metal powders. And there is a sloka, which meaning is that throw the flowing iron mixed with water in a broken pot and melt it, and then after washing the iron ore, they will put into the iron mortar with and also pound it with a pestle, so that there will be powder. The preparation process of charcoal, and what evidence suggests that various local woods, namely irul, teak, sal, babul or bamboo extra are used for producing dense and heavy charcoal, because you need to have the charcoal which will be dense and heavy for this kind of work. And they were aware that which wood will be giving, and they will always relying on the local material instead of getting from outside in the way we do in the present time. The dried branch of trees were cut and burned them in an open heap or inside a pit, so that pyrolysis will be occurring and the gases will go out and the carbon will be remaining. And once wood is charred, fire was extinguished by covering the burning wood with green leaves or twigs or sprinkling water on it. And beehive type firing chambers were also used for preparation of charcoal. This is a very good design. If you look at this, is being mimic from the nature, like if you look at the honey bee, they are having beehive kind of things. After complete extinguishing fire followed by adequate cooling, charcoals were collected, and also the proper size of the charcoal is to be collected. And they use also, and there is no evidence of lime or limestone being used as a flux, but however, the silica SiO2 and CaO present in the ore and charcoal ash can act as a flux for making iron slag to flow. The extraction from material used by the Ayurvedic method, that is satapatana, indicates use of borax as a flux. We will be discussing about that, how they were using the borax and in the particularly Ayurvedic method of making iron. In later time, lime was used as a flux in iron smelting in Ujjain MP and Bariat in Rajasthan. Right. So, these are the kinds of flux material what they were using to remove the slag during the smelting process. And there are various kinds of furnaces are being used in ancient time, and these furnace types will be varying from region to region. However, I will be discussing few of them because of paucity of time. So, and several small and large furnaces were used till 18th century for making iron. Of course, after that Britishers were having their own factory in other places, and they discouraged the people to have local irons. That is why those methodologies were lost. And of course, in modern India, we are not bothered about the indigenous manufacturing of the iron by the local people. And these furnaces were called bhatti, in some place koti, kosti, were made from locally available clay. The if you look at, these are very simple, and lot of innovation were being used by the various people to make them different and also to use the local material. The internal contours of some of the furnace were lined with natural china clay or refractory materials. The like what is even in today in blast furnace or other places, that the furnace lining are being used, particularly refractory materials are being used as a furnace liners. The furnace were made of either below the ground level or on the sloping of a hillock or above a ground level. There are various kinds one can see, and most of furnaces was having two holes, one for charging, other for the passage of molten slag. And generally tire and the pipe were used, pipes were used for supplying air. And classification of ancient Indian furnace, if you look at furnace in South India were having bowl shaped hearth and conical shaft. Cylindrical furnace of Madhya Pradesh, where bloom were removed from the top of the furnace. Koti type furnace of Bhopal or Ujjain with a square or rectangular cross section for a large production. That means they were getting something 250 kg per day, which is a quite a huge amount if you compare to other furnaces at that time. And let us look at a furnace which is known as Koon Furnace, and which is quite old. It goes back to 700 BC in Nalanda. This Naikund and even Khairadi and Ujjain, other places you can find. And this is a very simple furnace which is being used, like they use the clay bricks, and there is a tire what is basically supplying the air to be sucked in, and then this is the charcoals which are there, so also iron and the blooms, these are the iron blooms, and the slag are the will be moving out of this in this passage. And a typical one which will you might have seen in somewhere, even poor people use it nowadays, but of course it is not being practiced very much, and it is made from prefabricated clay bricks, whereas the furnace in western country were made by digging holes in the earth, right, in ancient time. So, there is another Dhatwa furnace. If you look at here, the smelting charges are there, again in the ground also it is being made, and then these are the burning coals, and you are having a bellows here that will be giving the air will be coming through that, and and bellows one can press it so that air will be sucking in and going. These are air passages. This is another kind of furnace which was there in ancient India. And let us look at a furnace which was used earlier days by tribal of Bishnupur, and this is the cross section. If you look at this is having a conical shape, and this is the tire, and the diameter here is around 500 mm, and on the top it is 150 mm diameter, and it is having the what you call support for with the help of a bamboo, and rope will be there. And if you take a, of course this height is 800 mm. If you take this cross section, you will get this one, that is the shape. In India, furnace in iron smelting and others seem to be reused after refining, relining it and repairing with refractive clay, unlike the cluster of furnace excavated in western countries which are not having liners, and they were using once and then after that they will not use it. So, that is the difference between the technology in ancient India whatever it was there. Let us look at how they were doing this kind of putting this air. There is a, as I told, there is a bamboo will be there, and then if I take this cross section here, this is the slag pits which is being not shown in this figure, and these are of course the blooms, iron blooms. This is a tire pipe which will be connected with the bamboo air pipes, and these are bellows. Bellows will be made of something hide or as what you call skin, and on which top of which people will be jumping on it, so that it will take air. The diaphragm will be moving up and down and then sucking air and going out. I will be showing a figure about that. So, if you look at what I was telling, this is the one, and which is with the help of a stick, he will be balanced, and you need to have a balance that. This is the bellows, right, on which will be like jumping on it rhythmically, right, and this is the tire. They use this. These are, if you look at clay tires which are being used, these are pipes through which air will be passing through it. This is for air pipes, right. And air bellows are made in the form of wooden trough with a cavity around 300 dia and 15 height, and near bottom of this 35 was made in the side wall to fix bamboo pipes are having 12 to 15 millimeter diameter and 500 to 600 millimeter length. Other end of this bamboo pipe was inserted in a large end of the clay tires, like from here there will be things, and it is carried to the furnace, because the bamboo will get burned, therefore, you will have to use a clay pipe. That means, they are using combination of bamboo and the clay pipe. The top of the wood trough was covered with moist piece of leather, and here the leather will be there, this is the place, and leather having a flap with a hole in the center, right, it will be moving up and down. So, that through which air will be coming going in and then passing through that. And there will be also what we call a valve which will be closing it, so that air will get into this leather, and then after that it will be go up, and then this air will be, when you push it, air will be getting into this pipe. This is a indigenous pump system, and which were operated by the what we call muscle power. And one has to do is rhythmical. That means, if you do this thing, you will have to also develop your mind. Not only the physical labor is required, also the mind coordination is important for operating this kind of bellows. So, let us look at another smelting furnace at Ghatgaon, and which is shown. This is like acting like a what we call natural draft, and this is the tire through which air will be passing through it. Of course, all dimensions are given here. If you take a drawing of this kind of furnace was constructed partially below the ground, because this portion is a ground level, right, unlike the Koon Furnace, which is on the top, right, above the ground level. So, as I told, this is the air tire or air pipe, you can say, through which air will be getting into this furnace for the combustion to occur, and then so that reduction of the iron will be taking place. There is another furnace which is at Jira Gora, and which is having of course a similar support, but here having what you call a slag drains, and this is your earth which is below the ground level, and this is a slag pit. If you look at this, will be a slag pit kind of thing, where slag will come and then be deposited there, and you can remove it. And this is your air passage tire which will be having. So, if you look at there are several design one can see, right, across the various parts of the country, and they were using their creative power to develop themselves, and of course, these are the support platform for this structure to remain. And there is another twin shaft furnace from Malwa region, and this I have shown here. This is the phase 1 and this is the phase 2 kind of things. These are the pipe holes, right, through which air will be. This is a slag pit, right, slag pit, and this is the hearth. And if you look at, there is a platform where you can take this out and everything. This twin hearth furnace was fitted with more than one pair of bellows for supply of air, and peep holes are located suitably for monitoring inside temperature furnace. That is a very interesting. That means, you can remove these holes and then see whether it is doing well or not. Accordingly, you will have to supply the more amount of air or reduce it. As per the Buchanan, it could produce 250 kg of iron per day. It was in 1807. If you look at something around 110 years back, we are having this technology. Unfortunately, today it is not there. In India, furnaces for iron smelting, others seems to be reused after lining and repairing with the refractory clay, unlike cluster of furnace excavated in western countries. This is the thing which I had repeated, which I had told earlier and now being repeated. So, that is the beauty of the ancient Indian furnaces which were used for making iron. Let me talk about another type of furnace which was being mentioned, which is being mentioned in Rasaratna Samuchaya, and in this furnace one can get around 1500 degrees Celsius, but other furnaces people are claiming you cannot go beyond 1200 degrees Celsius, right. And in this case this is the figure which being shown here, it is similar to that earlier, that means bellows will be there with the tire, and these are the what you call the charge means having coal and other things will be there, and here they will be using a crucible, right, and this will be charcoal, and through which air will be coming over here, right, and it will be burnt out, and then it will be burnt here, and then this thing. And generally this is being used for extraction iron from biotite. Biotite formula is given, and this is being used for basically for Ayurvedic medicines. Satapartana process, that is the sodhana, purifications, bhavana, the maceration and triturating, and dhamana is the heating and smelting, and liquid used for sodhana of minerals like kanji, fermented liquid, right. Basically if you look at it's a very sour buttermilk you can think of, and tripala quath, hadira, bahara and amla, right, is a Ayurvedic materials, and cow's urine and cow's milk. So, these are the way by which they will be purifying the minerals, and this process is accompanied with the intermediate bhavana leading to pelletization of charge like 20 to 30 balls they will be making, which is made of mica around 200 grams, borax 50 grams, muesli powders 50 grams. Of course, this will be acting as a reductant, and this will be mixed with this iron powders, and then will be kept in this crucible, and then you will heat it with the help of bellows, and then which can go to the very high temperature 1500 degrees Celsius the material. And the problem with this kind of method is that you will be getting iron in a small quantities, not in a 250 kg per day. And Rasa Ratna Samuchaya describes 51 kinds of metallurgical tools and 31 kinds of equipments, 17 types of crucible and 9 types of furnace and 5 types of coatings. That means, if you look at, there is a plethora of knowledge about the smelting process and their tools which are being mentioned about in this text. But now one has to look at it carefully and also look at what can be used today and how this knowledge can be transferred to the people, particularly not about textual knowledge, rather practical knowledge. That has not been done, and unfortunately I wish that some of you should take it up, not that you will depend on the government to do that, rather individual has to do it. Now we will be discussing about the difference between the blast furnace which is being used for iron in modern time. This is the one of the workhorse for producing the iron from the iron ore, and this is quite huge. If you look at this is the furnace which is containing this iron ore and limestone and coke, they will be putting it here, and there is also the temperature is being maintained. These are the fire clay and bricks, of course lining will be there, and this is the cup and cone for arrangement so that it will be flow very nicely, and the temperature is being maintained properly, that is very important, and the 1700 maximum temperature it can go up, and you will be using hot air. It is like is very important, whereas in our traditional we use the cold air, I mean normal or ambient air. And the slag which will be coming out, slag out, of course you will get the molten iron out kind of things. But the length, if you look at it, something 20 to 35 meter is quite huge. Of course the diameter 6 to 14 meter, and it can produce something 100 tons to maybe 1000 of tons of iron. This is very huge. Now, you want to compare with our earlier one with the blast furnace, this is very small, something height will be 700 mm, right. This is in meter, and this will be diameter will be something 300 or maybe 400 outer diameter. But this technique of blast furnace is quite involved and complex in nature, the chemistry. But here and this one has to go for 1700 degree Celsius, whereas the ancient process is the direct reduction reaction which will be occurring at 1200 degree Celsius. Fe2O3 will be reacting with carbon monoxide, will be getting into iron and carbon dioxide. And if you compare both the thing, this ancient furnace and the blast furnace is quite complex, and nobody can really change it that quickly because it is so huge. Whereas anybody can change this small furnace and you can innovate a lot of things and do that. And this is a lower temperature, therefore being used. As a result, you will can also cost will be very lower, but the quality of the iron one has to also look at it. But what people found out, this quality is comparable with the blast furnace, and but the quantity here it will be very less as compared to the blast furnace, but the quantity will be very high because it is a very huge. And so, therefore, we need to at least go back to this process, this ancient furnace, which will be with the people, but now the blast furnace with the company, right. There is a difference, and the knowledge if we will go for ancient furnace, the knowledge will be with the common people who will be using it. And if you look at there is a direct reduction method which is being used in ancient Indian furnace, that is iron ore you will have to do this beneficiation and then rich iron ore will get, that is true, and then wood burning you will get the charcoal. And this solid state reduction, which is known as also the Bloomery furnace, that is being used in ancient India, which will be operated around 1000 degree Celsius, 1200 degree Celsius. Unlike in the blast furnace 1700 degree Celsius you need to maintain. For that you need to use lot of energy for that and also the extra. And of course, you will get the fluid slag which is very easy to remove it, and you will land in getting hot sponge iron. And nowadays of course, people have talking about sponge iron which is cheaper than the iron being made in blast furnace, and you just hammer it and then you will get the iron lump, which is very easier process of getting iron in the ancient method, which is based on the direct reduction of the iron ore. So, operation of the furnace, if you look at iron ore to charcoal ratio, people had used something 1:2 to 1:4, and this should be charged in alternative layers. That means, if there is a iron here, iron ores, and there will be also the charcoal, right, layer by layer, there will be iron here and there will be charcoal. It has to be placed. Generally, charcoal is filled on the top of the furnace and firewood is ignited by inserting a small piece of burning charcoal, right. And when firewood is kindled, bellows are put into mouth and air is blown at a slower rate. The rate of air entering into the furnace will be small, and slowly the rate of blowing air is to be increased till the flame about 600 appeared at the top of the furnace. That means when you are igniting the because you are igniting from the top. So, therefore, once this flame increases then after that, like rate of operation bellows are controlled by observing the color and the height of the flame, and temperature inside will be ranging something 1100 to 1250 degrees Celsius, and one can also change this air flow rates depending on what temperature you want, and one heat of furnace requires around 10 to 15 kg of ore and 35 to 40 kg of charcoal. And if you look at today, we are using the coal, and which is not sustainable, but whereas charcoal is sustainable. That is also another important point one should keep in mind. because if we can grow the trees and then use it properly, then we can make it sustainable. After 4 to 5 hours reduction of iron, the rate of blowing is increased to raise the temperature of iron and slag, and then of course, one can keep it and then remove that thing. So, this operation goes on for kind of thing, but these are all manual driven furnace. And if you look at that, we have already discussed this. If you look at carbon is reacting with oxygen going to the carbon monoxide, and carbon monoxide is reacting with Fe2O3 getting to the iron and carbon dioxide. Now, if you take ratio of this carbon monoxide to carbon dioxide 80:2, that means this is basically 4 kind of thing, carbon monoxide to carbon dioxide ratio, that you will get somewhere this, if you look at this, a partial pressure of CO divided by partial pressure of CO plus partial pressure of carbon dioxide, you will be getting around something 0.8 kind of things. So, around 1200 or 1000 to 1200, if you maintain, you will get basically the iron very easily, right, in that even atmospheric pressure condition, right. That is the good thing, that this furnace being operated at atmospheric pressure. So, which is you can get if you maintain this temperature 1000 to 1200 kind of thing, you will get a iron. The above reduction of being exothermic, right, can provide sufficient amount of heat to maintain furnace temperature and form the phyllite rich liquid, that is the slag, so that which can be removed very easily. And of course, people have done various heat balance of iron making furnace at Jiragora. This is a recent work, and where people are trying to follow the ancient procedure and see that, and they have done all this calculation, as I told, CO, CO2 ratio 4, and they were getting that heat for heating the ore to 1000 degrees and something, they have done a carried out heat balance something 4920 kilocalories, heat for endothermic reduction 5451 kilocalories, and they have done all these calculations. They are finding out the radiation loss is around 18.5%. One can reduce it, then you can also enhance its efficiency. And the air blown in 6 hours is something 203 meter cube, air blown rate is 564 liter per minute kind of things they are giving, that is the kind of air. The conclusions can be made out of this analysis, that is the and also this discussion. The furnace charge balance was good enough to produce low carbon wrought iron, and the phyllite rich liquid slag requires addition of silica flux to produce recorded quantity of slag, and sufficient amount of air produced by two valves to produce measured temperature of 1459 degrees Celsius, which they had conducted experiment they could measure. So, one can see that means the method being used by in ancient time can be replicated even today, and we will be looking at how they were handling the sponge iron. The hot iron bloom from the furnace was hammered on the stone anvil to remove the liquid slag to a larger extent before it gets solidified. That means, once it is removed, it quickly has to be hammered, so that the slag can be removed. And porous sponge iron was repeatedly heated in the forge hearth to reforge and produce wrought iron. That means, this sponge iron will be converted into the wrought iron by the heating it, and also with applying the force. And secondary treatment of hot sponge iron is basically being done in the following way, that is, hot sponge iron something 3 to 9 kg was consolidated into semi porous mass and forging squeezing out the molten slag. With further removal FeO and phyllite, density gets increased further, right, and this block is repeatedly heated in the forge earth, as I mentioned in the just now, with sprinkling of silica powder, so that ferrous oxide gets converted into this eutectic as a semi liquid slag at 1170 degrees Celsius. By repeating the forging of iron piece, it is converted into solid rod of specific standard size, which can be classified as to ductility and strength. Of course, this process is being managed by the judgment and also by the person who is doing it. So, therefore, the quality is also one concern, and that means one has to very carefully do that, and this standardized wrought iron is further processed by blacksmith to produce various iron products. So, if you look at that, this is basically like the process which is being this is the process of iron smelting, and also the secondary treatment of hot sponge iron was discussed just now, and from this one can conclude that there is a very nice and systematic procedure were available at that time, and which of course we lost, but it can be revived provided we do some little bit research and then also transfer this knowledge to the people who can manage it. So, this will be can be developed as a cottage industries, and where the knowledge will be with the people, and also they can utilize the creativity with that. So, with this I will stop over. In the next lecture we will be discussing about basically various metal making processes of iron and how they are making a product and other things. Thank you very much.